Let's dissect a real Microsoft Fabric data ingestion design end-to-end. The scenario: a retail company pulls sales data from an on-premises SQL server and a cloud REST API, lands it in a lakehouse, and serves clean tables to Power BI. By the end, you'll know which Fabric component does what, how requests and data actually flow, where this pipeline breaks, and the trade-offs the architect weighed against Classic Azure Data Factory. Pricing and feature details shift fast, so confirm specifics in the current Fabric docs. Start with the layers. At the bottom is OneLake, the single Delta Parquet data lake every Fabric workspace shares. On top sits the lakehouse, which gives you both files and SQL queryable tables over that same storage. Above that, Fabric Data Factory provides two distinct tools: pipelines for orchestration and Dataflows Gen 2 for transformation. Everything runs on a Fabric capacity, the compute you pay for measured in capacity units. Recognizing these as separate layers matters, because a single slow data flow can starve the whole capacity that your reports also depend on. The most common confusion is pipelines versus Dataflows Gen 2, so let's be precise. A pipeline is an orchestrator. It's a directed graph of activities. Copy data, run a notebook, invoke a stored procedure, call another pipeline, with control flow like if conditions and for each loops. It moves and coordinates but does little reshaping itself. A Dataflow Gen 2 is the transformation engine, built on Power Query's M language, where you actually clean, join, and reshape data with a low-code interface. Rule of thumb: pipelines decide when and in what order things run. Dataflows decide how the data is shaped. Now follow the data. A trigger fires the pipeline on a schedule. The first activity is a copy activity reading from on-premises SQL Server. Because that source lives behind a firewall, the request routes through the on-premises data gateway, which holds the secure outbound connection. In parallel, a second copy activity pulls from the cloud REST API. Both land raw data as delta tables in the bronze layer of the lakehouse. Credentials never sit in the pipeline. They come from connections backed by Azure Key Vault references. Keep ingestion dumb and fast here. Save the cleaning for the next stage. Once raw data lands, the pipeline invokes a Dataflow Gen 2 to build the silver layer. Deduplicate, enforce data types, standardize keys, and join the on-prem and API records into conform tables. A second transformation step, often a notebook for heavier logic, aggregates silver into gold business tables ready for reporting. The pipeline orchestrates this ordering with dependency arrows, so gold never runs before silver succeeds. Because everything writes delta tables into the same OneLake, Power BI reads gold directly in direct lake mode, with no extra import or copy. That single storage design is the real payoff of Fabric. Now the failure modes, because no design survives first contact with production. The gateway is a single choke point. If that machine is down or unpatched, on-prem ingestion stops cold, so run it clustered. Transient source timeouts are normal, so set retry counts and retry intervals on copy activities rather than failing the whole run. Watch for capacity throttling. A long data flow can consume capacity units and slow concurrent reports since compute is shared. And design idempotent loads using overwrite or merge on delta tables, so a rerun after partial failure doesn't double your rows. Wire alerts through monitor and pipeline failure outputs. So why build this in Fabric rather than standalone Azure Data Factory? The trade-off comes down to integration versus control. Fabric Data Factory keeps everything in one workspace on one capacity, with native OneLake and direct lake serving, which collapses a lot of plumbing. Classic Azure Data Factory gives you more mature features, granular per pipeline cost visibility, dedicated integration runtimes, and proven scale for very large or complex orchestrations. My rule of thumb: if your analytics already live in Fabric, use Fabric Data Factory. If you need standalone ETL feeding many destinations or fine-grained cost control, stay on Azure Data Factory. Verify current feature parity before committing. To recap, pipelines orchestrate Dataflows Gen 2 transform, OneLake stores everything once, and a gateway bridges on-prem sources. Data flows from raw bronze through clean silver to business-ready gold, served straight to Power BI. The biggest risks are the gateway choke point, shared capacity throttling, and non-idempotent loads. Here's your one actionable takeaway. Before you build, draw exactly this separation of concerns: orchestration versus transformation versus storage, and decide which layer owns each step. That single diagram prevents the most common Fabric mess, cramming transformation logic into pipelines. Always cross-check capacity sizing and current limits in the Fabric docs. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.